Sarah is a busy professional who uses online banking time to time. One sunny afternoon, she receives an email from what appears to be her bank, asking her to verify her account details. The email looks legitimate, complete with bank logo and even a link to their website. Without a second thought, Sarah clicks the link and logs into her account, entering her credentials. Little does she know, while she's busy checking her balance, a hidden script in the email is silently sending a request to transfer money from her account to hacker's account. In the blink of an eye, Sarah becomes a victim of CSRF, unknowingly authorizing the transaction. A successful CSRF attack can be severe. For individuals like Sarah, it could mean a significant financial loss and emotional distress. For businesses, the stakes are even high. CSRF can lead to unauthorized actions, such as transferring funds, changing account settings, or even imitating a purchase, all without the user's consent. So, why CSRF happens in the first place? The root of this problem lies in how web applications handle requests. So, when a user is logged into a web application, their browser retains that session. If a malicious site sends a request to the legitimate site exploiting that session, there's nothing to stop it. Web apps will assume that the request is valid because it appears to be coming from an authenticated user. You can check out multiple CSRF reports on HackerOne. One of them was reported to Nord Security, where the attacker found a CSRF to change password. So basically, an attacker can create a request and send that to victim, and if the victim clicks on that link, the password will change for that victim automatically because a request is being sent to the server. Now, the victim doesn't know that he/she is sending the request to the server, but the request is being sent in the background, which changes the password. You can check out this report from the link in the description. Okay, now how would you spot CSRF vulnerability in a web application? How would you know if it is vulnerable or not when you are hunting? So there are some conditions that has to be met if you're looking for this vulnerability. First, you have to check for a functionality. So first thing you have to see if there is any action within the web application that the attacker has a reason to induce. For example, as we saw in the previous case, changing the password, that can lead to account takeover, or action that could modify the privileges of other users, like permissions, or any action that is modifying something, like changing email. Now, when you have identified it, you can check if there is cookie-based session handling. Check if the application is only relying on session cookies to identify which user is making the request and no other way of tracking sessions. Now, the third condition is there shouldn't be any unpredictable parameters. So the attacker cannot guess, as the attacker is going to craft a request. Now, if there is an unpredictable parameter, the attacker cannot craft the request. That's why this condition is also important. For example, when causing a user to change their password, the function is not vulnerable if an attacker needs to know the value of the existing password. Now, these are the three conditions that you have to keep in mind. If these three conditions are being met, then the application is vulnerable to CSRF. Okay, let's talk about how the CSRF flows looks like. First, the user clicks on the malicious link. The user clicks on a link or visits a page that the attacker has set up. This link contains a request to perform a specific action on the target web application. For example, it could be a link to transfer money from the user's account to attacker's account. Second step is request to target application. When the user clicks on the link, their browser automatically sends a request to the target web application. Since the user is already logged into the website, their browser includes any relevant authentication tokens. In this case, it has to be session tokens with the request. Now, third step is server processes the request. The target website server receives the request and interprets it as legitimate action initiated by the user because the server doesn't know who sent the request. It sees the user authentication token or session and assumes that the request is authorized. Fourth step is action is executed. The server executes the action specified in the request without further verification. For example, if the request is to transfer money, the server transfers the specified amount from the user's account to the attacker's account. Step 5 is response sent to user. Once the action is executed, the server sends a response back to the user's browser. This response could be a confirmation message, a redirection to another page, or any other appropriate response based on the action performed. Step 6 is user sees the result. The user browser receives the response from the server and displays it to the user. Depending on the nature of the action performed, the user may see a confirmation message or notice that something unexpected has happened. So for CSRF to work, the victim should be already logged into a web application, as the session cookies will be added automatically by the browser. Here, same-site cookies plays an important role. How? Well, when the victim that is already logged into the web application already clicks on the link and the browser sends a request to the server automatically, it includes the session cookies automatically as well. But this only happens when the same-site cookies are not used. What do I mean by that? What is same-site cookies? Same-site cookies are directives that developers include in the HTTP request while setting cookies. They include it in the set cookie header to specify how the cookie should be handled in cross-site request. When I say cross-site request, I mean request that is not being originated from the web application itself, but from a different web application. That's why it's called cross-site. So when the attackers create a malicious page for CSRF and the victim clicks on it, the request originates from the attacker-controlled server to perform an action. So basically, a cross-site request is being sent to the server. If there are no same-site cookies set or cookie attribute set to none, then it's vulnerable. So you have to check that as well in the set cookie. So you will see a directive something like same-site equals strict. If it is strict, then it is not vulnerable. But if it is set to none, then it is vulnerable. Okay. Now let's talk about prevention methods. To prevent CSRF vulnerabilities, a developer can use CSRF token and include them in each HTTP request. So a CSRF token is a unique, unpredictable value that the server set to the client to include it in subsequent HTTP requests. Once the token is issued, the server checks the expected token, and if it's not there, reject the HTTP request. CSRF tokens can prevent CSRF attacks because they prevent attackers from fully creating a valid HTTP request, which they can feed to a victim. Another method is setting same-site cookies to strict value or lax value. When a cookie has same-site equals lax value set, it means that the cookie will be sent with the same site request. Example, request originating from the same site that set the cookie. Example, clicking a link to the site, but not with other cross-site requests like images or iframes. Another value is strict. When a cookie is set to strict, same site equals strict, it will only be sent in the requests originating from the same site that set the cookie. This means that the cookie will not be sent at all with cross-site requests, including when a user clicks a link to the site from another site. Using strict value provides a higher level of protection against CSRF attacks, but can affect functionality that relies on cross-site requests, such as social media sharing buttons or embedded content. These days, Chrome enforces lax value in same site by default. Another common defense is using referrer-based validation. Some applications make use of HTTP referrer header to attempt to defend against CSRF attack, normally by verifying that the request originated from the application's own domain. Now, even some of the prevention methods like referrer header or CSRF tokens can be bypassed. Now, I cannot cover this in this podcast because it is more like a practical approach. So if you would like to learn more about it, you can comment it down and I can make a separate video on it. I hope you enjoyed this episode of Web Ghost. Thanks for tuning in, and I'll catch you next time.